In this lesson, we're going to model real-world data using Scatterplots and then put a line of best fit in there. We're going to do this by hand on this lesson, and then tomorrow in class we will use our calculators and figure out how to do it by a calculator also. To start, you'll see that we have data here that talks about the average fuel efficiency in miles per gallon of new cars manufactured during the years given. So we have a little table here. They actually made our scatter plot for us, so you can see those blue dots on the graph. And we are going to draw what's called a line of best fit. The goal of a line of best fit is to try to make data that doesn't appear linear be linear, meaning I can't connect these dots with a straight line, but I want to try to find a line that would fit the dots best so I can make the data fit a linear function and make some predictions about it. So I'm going to draw a line and try to find one that fits in at least a few of the points. So for example, here's a line that I could use for the line of best fit. For doing it by hand, you have to connect two dots because otherwise we can't find the slope. On your calculator, you won't need to do that. It'll do it naturally for you, but if you're doing it by hand, you have to pick 2 points that you draw your line through. This one is a decent point that I picked because I'm going through these two, which is good. I'm a little bit away towards the bottom here, and this point's a little bit to the top. So it's not bad. I can choose this one and it'll work well for me. So once I pick my line of best fit, I'm then going to take the ordered pairs and write them down. So I used, the first ordered pair was 1960 and 15.5, and I'm getting that from the table right there. The second ordered pair I picked is the 1980 and 22.6. So to write the line of this equation, I'm going to try and write it in slope-intercept form. So first I have to find the slope. I would take change in y over change in x. So I'm going to take 22.6 minus 15.5 divided by 1980 minus 1960. So then when I do that, I would get 7.1 over 20. So I find the slope to be 0.355. In our class, if they don't tell you how to round, our default for the class is hundredths. So I would write this as 0.36. That's my slope of this line. Then I can choose which ordered pair I want to use to find the equation in point slope form first and then slope intercept form. So I'm just going to use the first equation, or the first ordered pair. I would then have y minus 15.5 equals 0.36 times x minus 1960. This is in point slope form. They will want these in slope intercept form. So I'm going to go ahead and distribute that 0.36. So I'd have 0.36x minus 705.6. And then to continue that, I would add 15.6 to both sides. So I now have y equals 0.36x minus 690.10. This is the equation of that green dashed line. So I'm just going to write it up here so we can see it with the graph. That's the equation. So as I look up here, the green dashed line is this equation. It's called the line of best fit. Some will call it a linear regression line. What we use it for then is to make predictions about what fuel efficiency should be in the future. So let's just take our current year, 2012, and I'm going to plug that in for x. What should the fuel efficiency be for this year? So if I plug in 0.36 times 2012, and then minus 690.10, and I'll do that all on my calculator. So 0.36 times 2012 is 724.32, and then minus 690.10, I'd get 34.22. This is how many miles per gallon new vehicles on average should be coming out the lot with. So we will talk about this a little more tomorrow when we do the calculator one. But this is a big deal. People want to know if we're up on fuel efficiency or not. In the political campaigns, this is something people talk about. So you see where we were projected to be, and then you can see if we actually are there, and if we're not, maybe why aren't we, and what's gone wrong. So there's how you do one by hand. The next one we're going to do by hand, our last one. This one, they didn't do the scatter plot for us, and they don't actually have a word problem with it. It's just a table. So we're going to go ahead and plot each of these points. It's a little bit tricky to plot these just because they aren't numbered by ones, they go by eights, and so you have to kind of find your way. So 5, 9, I'm going to put it right here. Do the best I can. 1017, we'll go right about here. 2022, right about here. 2530. 3538. And 4044. That's off my graph. You'll notice I'm not going to plot the 50 and question mark. This is what they want us to predict. So this is the one we're going to find out after we find our line of best fit. So to draw a line of best fit, I now try and find a line that somehow fits these points well. So when I do that, this one isn't bad, I just did it really fast. I can go right here maybe, and you can see how I am going through a couple of points, and then I have a couple below and one above. I also could maybe rotate this a little bit, go through those 3 points there. Does that look alright? I think that's even better of a line, because now I have these below but one above. So I've kind of found a line that fits. You might not pick the same points as me, and that's okay. You're just trying to find the best one that we can do by hand. Doing it on a calculator tomorrow, you'll see that it's much more accurate. So now I'm going to name a few of these points that I picked. So I'm going to go with this one and this one, just because they're the first two that I went through. So my ordered pairs that I would use for that would have been 1017 and 2530. That's those 2 points. So again, find the slope. 30 minus 17 over 25 minus 10. I would get 13/15 for my slope. I'm going to go ahead and make that a decimal, so I will use 0.87. Then I'll pick an ordered pair to plug into point slope form. We'll just use the first one again. Y minus 17 equals 0.87 times x minus 10. We're going to go ahead and distribute that 0.87, so 0.87x minus 8.7. Add 17 to both sides. I take negative 8.7 plus 17. Keep everything else the same. I would have y equals 0.87x plus 8.3. This is the equation for that line right up there. So now the last thing we would do is actually plug in the value that they give us. So we had 0.87, and then for the x value they ask us to find 50. So I'm going to plug a 50 in there, and then plus 8.3. So 0.87 times 50 would be 43.5. Add the 8.3 in there, and our value, that's the question mark they were wondering about, is 51.8. Again, tomorrow we will look at doing this on our calculator.